time to begin your lengthy review for quadratics. I would encourage you to fast forward to the section that you're having trouble with because this will be a decently long video. Alright, this first one, when we want to try to factor these, to try to find the zeros, it's going to say whether we want to factor or not. For this one, we're going to try to factor. We would say factor to 5, but subtract to give you 4. That's 5 and 1. We get a minus with 5 because it's a bigger number. Make it equal 0. That means each one equals 0, so x should equal 5, and x should equal negative 1. Now, if I wanted to, I could have done this one with completing the square, and I said number 1 would be a good one to try. So I would rewrite it first by saying x squared minus 4x equals bringing this 5 to the other side, so equals 5. From there, I want to add the same number to both sides. What number is that? I take this number in the middle, divide it by 2, which is 2, square it, which is 4. Add that number to both sides. Now I have x squared minus 4x plus 4. That can be rewritten as x minus 2 to the quantity squared equals 9. From there, take the square root of both sides. X minus 2 equals plus or minus 3, because that's the square root of 9. Okay, add 2 to both sides, so 2 plus or minus 3. That means if I do plus, 2 plus 3 is 5. If I do minus, it's negative 1. The same answers that I got before. Alright, number 2, back to factoring. Factors of 2 that add to 3 are 2 and 1. So x plus 2 and x plus 1. So I should have x equals negative 1 and negative 2 as my answers for that one. Alright, down here at number 3, it's factor again. Factors of 24 that add to 11. I should have, should be 8 and 3. 8 and 3, plus in the back means it's the same sign, they're both negative. So I should get x equals 8 and x equals 3 as my two answers. Number 4, factors of 10 that add to 7. Always read it right to left. That would be 5 and 2. That means that they're the same. They're both positive. So 5 and 2 are my points on the inside. So I should get x equals negative 5 and negative 2 as my two answers for number 4. For number 5, factors of 35, subtracting the 2. That should be x minus, or we don't know yet, but it should be x plus 7, x minus 5. And the reason it's a plus 7 is because this sign goes with the bigger number. So 7 is obviously the bigger number. So I should get x equals negative 7 and x equals 5. Let's do another completing the square problem with number 5 here, so you can see what it looks like. I would have x squared plus 2x would equal now 35 on the right-hand side. The number I'm going to add, divide 2 by 2, which is 1, square it, which is, well, 1. So add 1 to both sides. What I do from there, it's now 36 on the right. This will factor to be x plus 1, the quantity squared. Take the square root of both sides. X plus 1 equals plus or minus 6. So x will equal negative 1 plus or minus 6. So that means x equals one of two numbers. If I add them, I should get 5. If I subtract them, I get negative 7. Again, same two answers I had before. Alright, number 6, factors of 60 that add to give you 23. They're both going to be negative because x positive in the back, they both get the sign from the front. And those factors are going to be 20 and 3. So that means my answers are 20 and 3, both positive now. Alright, moving on. I'm going to try to do these both different ways for each one of these, just so you can see whether it's the table method or the squared or the regular, I won't call it regular, the other method, the old school method, I guess, just because it's the way I do it. If you do this the old school method first, let's start with that. I'd have 5x squared. I want to ask factors of 5 times 2, which is 15, that add to give you 2. Factors of 15 that, subtract to give you 2. It should be 5 and 3. So instead of a plus 2x, I want a plus 5x and a minus 3x. That way it's still a 2x minus 3 equals 0. I then go and I take the first half and I factor that. I could pull out a 5x, I'd be left with x plus 1. I need to get this term again with this one, so I'll pull out a negative 3 and get a x plus 1 as a result. My two factors are 5x minus 3 and x plus 1. So that means my answers are, I should get x equals, when I bring this one over, I would have positive 3, then 5 by 5. This one will be negative 1. Let's do number 8 with the table method. So I would make my table here. I would put the 2x squared up top, and I will put the 7 down here. I multiply those and get 14. Factors of 14 that add to 9 are going to be, well, just 7 and 2. So I make those 7x and 2x. I'm going to factor out, what can I factor out? An x, nothing, so just a 1. Going down, I can factor out a 2x and a 7. That means my two factors are 2x plus 7 and x plus 1. They both equal 0, so that means that I now have x will equal negative 7 over 2 when I do that one, and negative 1 when I do number 8. Alright, I'll do a table again for number 9. I'll have 3x squared and negative 12. So factors of 36 that subtract to give you 16. That's going to be 18 and 2. And we have a negative 18 because we want a bigger negative. I'm going to pull out, going up and down, I'll pull out just an x. And when I go up and down here, I'm going to pull out a negative 6. So x minus 6 there. Okay? When I go across, I'm going to pull out a 3x. And when I go across here, I can pull out, again a 2 for this one. So my factor here should be 3x plus 2 and an x minus 6 equals 0. So that means x should equal a negative 2/3, and it should also equal a positive 6. Alright, let's go back to the old school method for number 10. I'd have 6x squared, factors of 36 that add to give you 13. 36 that add to give you 13 would be 9 and 4. They're both going to be negative. Plus 6 equals 0. So, pull out a 3x from this first term. I'm left with 2x minus 3. I need to get the same thing, so I'll pull the minus 2 and have a 2x, not plus anymore, it's minus 3 for my second one. My two terms are 2x minus 3, what I pulled out, and 3x minus 2, what was left behind, or I said that backwards. Okay, that means that x will equal, I'll have a positive 3 over 2, and I'll also have a positive 2 over 3 as my two answers. Alright, let's do old school for number 11. Let's say I have 4x squared, I have a plus 3 at the end. Factors of 12 that add to 7, well, it really just is 4 and 3. So that broke down into 4x and 3x. I'm going to pull out a 4x out of the first term, and I'll be left with x plus 1. I'll pull out a 3 from the second term, and also be left with x plus 1. So my first factor is what was left over. My second term is what I pulled out. And now I set each one equal to 0, so I should have x equals negative 1. And I should also get x is equal to negative 3 over 4. Alright, let's try another table down here for number 12. And for number 12, I'm going to have here, I'll go 7x squared. I'll have a negative 8 down here. Factors of 56 that subtract to give you 30. Well, those numbers end up being 28 and 2. So it doesn't matter which one. So yeah, it should have been plus here at the end. That would help if I have the sign written down right. So let's try again. Factors of 56 that add to give you 30. So yes, that should be 28x and 2x. That way I get to a negative 30x. And when I factor out, I can pull out an x going down. I'll pull out a negative, I can pull out a 4 for that, so I'll pull a 4 there. And then when I go this way, going across, I should be able to pull out a 7x, and I should be able to pull out a minus 2 here for that. That way I'm left with this x minus 4, which I want. So 7x minus 2 times x minus 4. Those are my two factors. So x should equal positive 2 over 7 and a positive 4 for number 12. Alright, 3 more to do. Let's go old school. For 13, I'm going to first say factors of 180 that subtract to give you 27. Or add, I'm sorry, again, to give you 27. That's going to end up being 12 and 15. They're both negative because of that. So 10x squared minus 12x minus 15x plus 18. Factor out what I can. I'll factor out 2x's here. Leaves me with 5x minus 6. I want to factor out a minus 3 here. That way I'm left with positive 5x minus 6 again. So 5x minus 6 for the first, 2x minus 3 for the second. So I'm left with x equals 6 over 5 and x also equals a positive 3 over 2, 6/5 and 3/2. I'll give you one more table method to look at. I have 11x squared, negative 5 down here. So my factors are, my question is, what factors of 55 subtract to give you 54? That's a pretty easy one. 55 and just one, single x. I should have a minus with the 55 because it was negative 55x. I can pull out here an 11x. I can pull out here, I can't pull out much of anything, but I'll pull out a 1. When I go down, I can pull out just an x. And when I come out down here, I'll pull in a negative 5. So I should have 11x plus 1 and an x minus 5. So that means I can get this as x equals negative 1 over 11 and also a positive 5. And number 15, let's do this. Well, we can either do it factoring, or I'll do this one with completing the square again, so we can do that one last time. X squared plus 14x. I'm going to have 72 now on the other side, and the number that I'm going to put in between here was 14 divided by 2 is 7. 7 squared is 49, so I have 49 to both sides. I'm now going to have here on the left, it'll be x plus 7, the quantity squared, will equal, when I add those up, I get 121. Take the square root of both sides, plus or minus 11 now on the right-hand side. I need to subtract 7 from both sides, so negative 7 plus or minus 11. That means if I do the addition part, I'll have a positive 4. If I do the subtraction part, I'll have a negative 18. And those are my two answers for that problem. Well, like I said, you won't have quite this many, but you will at least be able to do some of each kind. Alright, now in these ones, we also have to do the quadratic formula. So, let's go through quadratic formula for all these. Remember, your formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if I have to sing it for you, well, then we're in deep trouble because you should know it by now. So, x will equal negative b, so it's positive 5, plus or minus the square root of b squared minus 4ac. And that's a negative 14 over there, all over 2a, all over 2 times 1. So I'll simplify that. This will be 5 plus or minus, this is the square root of a negative times a negative becomes a positive. So 28, if it was times 2, so it would be 56 plus 25. Comes the square root of 81 here, all over 2. Square root of 81 is 9. So 5 plus or minus 9 over 2. If I add, I'll have 14 over 2, which is 7. If I subtract, negative 4 over 2, which is negative 2. For the next one, negative b plus or minus the square root, b squared is 4, minus 4 times a times c, all over 2a, so 2 times 2, which would be 4 on the bottom. On the inside here, this will become 96, because I have negative negative, so 4 plus 96 will give me a 100 on the inside of the square root over 4. So negative 2 plus or minus square root of 100 is 10 over 4. That means that if I add, I should have 8 over 4, which is 2. If I subtract, negative 12 over 4, which is negative 3. Number 18 here, x will equal, again, negative b. Negative of negative 3 is a positive 3. Plus or minus the square root of b squared minus 4ac, all over 2a, all over 2 times 2 again. So what I'm going to have here, 3 plus or minus, I have 8 times 5, which is a 40. I have negative times a negative gives me positive. So 9 plus 40 is 49, all over 4. So I'm going to have now equals 3 plus or minus square root of 49 is 7 over 4. So my answers are, when I add, it'll be 10 over 4. When I subtract, it'll be negative 4 over 4, which is negative 1. I should probably simplify that, and that would become 5 halves and negative 1 as my answer set. Number 19, x will equal negative 4 plus or minus the square root of 4 squared minus 4 times a times c, all over 2a. So, negative 4 plus or minus is inside. 4 times 3 is 12. 16 minus 12 is 4. all over 2. Square root of 4 is 2. So negative 4 plus or minus 2 all over 2. That means I'll do, if I add, I'll have negative 2 divided by 2 is negative 1. If I subtract, negative 4 minus 2 is negative 6. Minus 2 is negative 3. And this last one, x equals negative b. Plus or minus the square root of b squared minus 4ac all over 2a. That means negative 3 plus or minus, simplifying the square root, 4 times 2 is 8. 8 times 20 is 160. I want to do 9 plus 160. So I'm going to have 169 on the inside and now 4 on the bottom. So negative 3 plus or minus 13 all over 4. If I add, that means I will have 10 over 4 again. And if I subtract, I will have a negative 4. That 10 over 4 should probably reduce to 5 over 2. Alright, now we move on to transformations of functions. We need to describe how these functions have been transformed. Okay? Always start with the outside. It's the easiest because we have something on its own. That positive means it's been shifted up by that many units, up 6 units. On the inside, it's something horizontal. When we see a negative, that means actually we go to the right by that many units, right 4 units. The inside is always the one that ends up being backwards. Alright, number 22, same thing. We're going to start with the outside. This is going to be down 2.5 units. I can also say I'm going to shift to the left by 7 units. And then this 3 on the outside means I'm going to have a vertical stretch by that factor. So I say vertical stretch by a factor of 3. By a factor of 3. 23. First of all, I have a negative out front. That means that I am flipping it over the x-axis. So I should have a reflection going on here. Reflected over, flipped over, either way. Right here, the minus 7 means I'm going to shift to the right by 7 units because it's on the inside. I have nothing out here on its own, so I'm not going up or down any at all. 24 has the most going on. Let's start with stretches. I'll have a vertical stretch, and that'll be by a factor of 2 because it's on the outside. I'm also going to have a horizontal stretch, and that's going to be by a factor of 3 because that's what's on the inside. Okay? Negative 1 on the outside means I'm going down 1 unit, and this minus 7 on the inside means I'm going to go to the right by 7 units there. We don't have to worry about the other numbers, just what the singularity numbers are, the ones without x's attached to them. Number 25, we'll start with here, a number on its own on the outside. That means I'm going to be shifting up that many, up 300 units. And then nothing on the inside. I have right here what's going to be a vertical shrink in this case because we have it getting fatter. We have something that's a fraction. So a vertical shrink, we're going to say that that's by a factor of 1/2. Number 26, let's start with this shrinking here. We have another fraction. This is going to be a horizontal shrink, and it's going to be by a factor of 1/3. I have a plus 4 on the inside. That means I'm shifting left that many units, so left 4 units, and I'm shifting up 8 units for the outside. Remember, when we do the inside, it's always backwards of what you would think. Instead of this being right like you might think for a number line, you're actually doing the opposite. You're going to be going down. 27, this is the easiest one here. All we're doing is reflecting or flipping over the x-axis. That's all we have going on there because there's nothing else on the inside in parentheses, nothing on the outside on its own. And this one, we're going to go up 2 units first, and we're also going to vertically stretch, and that'll be by a factor here of 1.5. So everything is being multiplied by 1.5. Alright, 29 to 32 is we need to rewrite them back in these forms based on now what these shifts are. So to shift up 2 units and to the left 5 units, that means that I'm going to have plus 2 at the end for the up 2 units, And on the inside, I'm now going to have x, I would need plus 5 to make it shift to the left. For the next one, let's do another color. Let's go green here. If I say f of x equals, it's vertically stretched by a factor of 4, and the 4 goes out in front. It's shifting up 7 units. And on the inside here, it's not going left to right at all, so that's just x. So 4x squared plus 7. In fact, really I should get rid of those parentheses and just say 4x squared plus 7. Alright, let's go to the next one here. Reflected over the x-axis, shifted to the right 1 unit. So reflection gives me the negative to the right 1 unit, so that should be x minus 1 squared. Not going up or down, so I don't need anything on its own. And the last one, going to have the most going on here. Vertically shrunk by a factor of 1/6. So we'll start with that. The 1/6 in front. Shifted down to 12 units, so that's a minus 12. Shifted left 8 units, so that should be x plus 8 to make it go to the left. Alright, coming down the home stretch now. These ones we're now graphing using these transformations. So, what I'm going to start with is how am I going to move this? This is going to be moving down 6 units. I'm sorry, this would be to the right 6 units and down 4 units. So that means that my origin is now at this point here, which is 6, 4. And from there, I want to go how I would normally go. So if I move over 1 to the right, I should move up 1 to the right, because 1 squared is 1. If I go from the origin and move 2 to the right, I should be going up 1, 2, 3, 4 in either direction. So now I have about 5 points. That's a good route to go to be able to get everything that I need. Alright, in this one, I'm going to be going up 3 units, and I'm going to be going to the left by 1 unit. So my origin now was here, now I'm going up 3 and to the left 1. There's my origin, and that is at negative 1, comma 3. This negative means instead of going up 1 over 1 or up 2 up 4, that means I'm now going to go over to the right 1, and now I'm going to go down 1, over 2 and down 1, 2, 3, 4, if I mark it as 1, 2. And I do the same in these directions. Now 1, now 1, 2, 3, 4, that'll put me right there. Actually, that should be 1 more spot over. So, now I can connect the dots. Now I have my graph. In this one, I'm not going up or down any, I'm just going left or right. This is telling me left by 7. So I'll go out like that, see if I can extend that line a bit. And I'm going to have here, starting with 1, 2, 3, 4, 5, 6, 7. This is my origin now at negative 7, 0. This one I have a vertical stretch going on here. So if I have my tally marks here, I'm going to be going, instead of up 1 or over 1, up 1, I'm going to go over 1, up this number, up 2. So my next point should be at negative 6, 2. When I went over 2, I normally would go up 4, now I'm actually going to go up not 4, but 8. I'll be up here somewhere. Same going the other direction. So my graph should look something like this for that graph. In 36, we're going to start by going down 4, and we're not shifting left or right any, so that's easy there. So my origin has moved down 4, so it's now at 0, negative 4. And same thing, this vertical stretch, instead of going up 1, or over 1, up 1, I'm now going to go over 1, up 1 times 3. So 1, 2, 3. For my next point, instead of going over 2, up 4, I now have to go up by that times as many. So I need to go up by 4 times 3, which is 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, let's make it 10, 11, 12. So about this point, which should be 1, 2, 3, 4, 5, 6, 7, 8 up there. And I need to go the same going in this direction to connect it and make my U that way. It should be nice and skinny, which you should have known because this makes him skinnier, makes him taller. Alright, in this one, we are going to be going up 6, and we're going to be going to the right 1 from my origin. Now, after that, what do we have to do? So over 1 and up 6. 1, 2, 3, 4, 5, 6. So there's my origin now at 1, 6. Instead of going over 1, up 1, I have to go by this number in front. So over 1, only up a half. Left 1, up only a half. Instead of going over 2 up 2, or up 4, I'm only going up 2 now. So I should be right there and right there. I should have a bit of a fatter graph going on there. And this last one here should be down 8. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 1, 2, 3, 4. Just do that for now. I should be going down 8 and to the left 3. So that should be my new origin. This should be the point -3, -8. And there's nothing out in front, so my normal of going to the right 1, up 1, and to the left 1, up 1. To the right 2 would be going up 4, 1, 2, 3, 4. Same in this direction. So there's that side, there's that side, there are my graphs. Alright, down the home stretch now. Now we need to do it with the x-intercepts, the y-intercepts, and the vertex point. Remember, we always do the vertex. Write this up here. The vertex is always that x equals -b over 2a. So, starting with the x-intercepts is always just when y equals 0. More often than not, I should be able to factor this. So x, it should end up being x plus 6 and x minus 2. That means x will equal -6 and +2. So, drag this down a little bit, give us some room. We're going to have x-intercepts at -6, 0 and 2, 0. So I'll mark those. So at -6, 0 and at +2, 0. And I should really mark these points when I do them. -6, 0, 2, 0. Y-intercept is when x equals 0. So 0, -12. That's this point right here. 0, -12. And my vertex point is at x equals -b over 2a. So -b is -4 divided by 2 is -2. To find this the y value for this, I need to plug in -2. And when I do that, I should get -16. So this one goes off of my graph. It should be down here somewhere, about -2, -16. And this is a terrible sketch of the graph, but as long as you're close and as long as you have those points marked, I can't mark you wrong as long as your points are correct. -2, -16. Same thing for this one. Let's factor it. For number 40, I should have x plus 2, x plus 4. When they're equal to 0, it means x is -2 and -4. There's -2 and -4. -4, 0, -2, 0. Those are your x-intercepts. Y-intercept will be at +8. So 1, 2, 3, 4, 5, 6, 7, 8. So that's 0, 8. The vertex will occur at -b over 2a. So that's -6 over 2, which is -3. Plug -3 back in here. 9 minus 18 plus 8 will give me a -1. So this point here is -3, -1. And now I can draw my u. 41. Y-intercept is actually going to be at -6. 1, 2, 3, 4, 5, 6. So that's my 0, -6 there. I'm also going to have my x-intercepts. Let's factor this if I can. So I'm going to factor out a 2 first. I'll have x squared minus 2x minus 3 left, which means that'll go x minus 3, x plus 1. So that means I'm going to have x equaling 3 and -1. So at +3 is one point, at -1 is the other point. -1, 0, +3, 0. My vertex, -b over 2a, +4 divided by 2 times 2 is 4. So I'm going to have at the point 1, when I plug this in, I'll have 2 minus 4 minus 6. So I should get a -8 for my vertex for y value. So 1, comma, -8 is my vertex. So that's where it should shift back up. That's where it should shift back up. Number 42. I first want to factor out this negative, x squared plus 4x plus 4. When I do that in this one, I'll have x plus 2 times x plus 2. When I set those equal to 0, that just means x will equal -2. So I only have one intercept here. Now what you may have noticed by now is that that's what my vertex is going to be as well. When I only have one intercept, it must occur at the vertex. So -b over 2a means +4 over -2, -2. And I already found the y value, it must be 0. That's what that intercept must be. It's negative, so it should go downhill. I can confirm that with my y-intercept of -4. I could have also made another one this way, and I can draw my graph here. There's 0, -4. This point is -2, 0. Alright, 2 more to go. I factor this as x minus 5 and x minus 2. 7 equals 0, so I should get x equals 5 and 2 as my answers. My y-intercept, I'll need to draw these first. So I'll have positive 5, and I should have a positive 2 as my 2 points. So there's 5, 0, and there's 2, 0. My y-intercept occurs at positive 10. So that's going to be way up here at the point 0, 10. And then my vertex point will be negative b over 2a. So it will be positive 7 halves. And when I plug that in, this is the same as saying I'll call it 3.5 to make it easy. And it'll be negative 2.25 as my y value. So 3.5 and a little less than negative 2. So 3.5, negative 2.25. Now I have everything I need to make my graph. Last one, I'm going to factor this as 6 times x squared minus 1, which is 6 times x plus 1, x minus 1. When it equals 0, that means x equals plus or minus 1. So I have negative 1 comma 0 and positive 1 comma 0. My y-intercept is at 0, negative 6, 0, negative 6, and my vertex point is negative b over 2a. Well, I don't have a b, so that means my y value, or my x value is just 0. And that means that my y-intercept, we already knew, of negative 6 is where my y value is for the vertex. So now I have a nice skinny view to end it off. There you have it. Best of luck. And that's pretty much everything you want to know, and probably then some about your quadratics.